I design a lot of geothermal systems, and they typically require a custom solution, right? High-end residential. It's a different market. So tell me about the innovation, what you guys are working on here.
Absolutely, yeah. So one of the steps that we've done right off the bat is standardize a lot of the way that we design and engineer the systems. So we use design software to properly size the unit, to make sure the geothermal well is properly sized, and that just helps the overall efficiency of the project.
Gotcha.
What we've also done is that we're reusing any existing infrastructure that we can. So in this case, the existing air ducts.
Gotcha. Okay.
And so you can see here we've cut off the existing ducts and added our new system in, and just added these flexible duct
So it's pretty
connectors.
much plug and play, right? Plugging it in here, connecting between the supply and the return.
Exactly. So
Nice.
the home used to have an air conditioner outside, natural gas furnace inside. What we've done is pulled that old unit out, coil, condenser, furnace, and we've capped the natural gas lines. And now we've got one single geothermal unitary system.
So no more outdoor condenser.
No more outdoor condenser, which is great. Yeah, and you'll notice too that one of the things you'll typically see in a geothermal system is a separate pump box that has your pumps and some of the flushing ports in it. We've put all of that into one unit to make the installation process that much faster and smoother. And installing things in a factory is much faster than doing it in the field.
Sure.
And so what you'll see here, what we've got is two pumps that pump through this piping and out to our geothermal well. And it's pumping a mixture of water and a little bit of glycol just to account for any possible freezing conditions.
Okay.
And so that water then is moving through a heat exchanger inside the tank or inside the unit that exchanges with the refrigerant that's all self-contained inside the box.
Gotcha. So on the air side, I see the return ducts coming in here.
Exactly.
What happens next?
Yeah, so this is just like any typical system where you're pulling return air across a refrigerant coil that the fan is pulling and pushing out through the rest of your existing ductwork.
Got it. So in the wintertime, when the air is cold, it's coming in right across that coil, warming up, and then being delivered to the supply duct into the space.
Exactly. And then it's just a continuous cycle where we're then going back and getting more heat from the ground and pulling it back to your heat
That's great.
exchangers.
That's great. Awesome. What about the blue pipe?
Yeah, you'll notice that we've got this extra piping here that this is going over to heat your hot water for things like showers or dishwashing.
So domestic water.
Exactly.
Okay.
So in cases, for example, like the summertime where you've got extra heat from the heat pump, before we send that out to the geothermal well, we can send it into a preheat tank. So this tank here is just like any other water heater, but we've just not connected it to any power, right?
Gotcha. Okay.
So the cold water comes in here and we can heat it with that excess geothermal before it goes into your traditional water heater.
Got it. So it's commonly called the superheater or preheat tank
Exactly.
connection. Got it. And so your electric water heater doesn't have to work as hard because it's got preheated water.
Exactly, yeah, and it's basically this, can heat anywhere from 20 to 30% of the home's annual domestic hot water use.
Okay.
It just makes the primary water heater have to work a little less hard.
Yeah. So it's all electric, the whole system.
The system is all electric now, which is really great. If you can then pair it up with something like solar on your rooftop, then your home becomes a lot more sustainable.
Really exciting.
It is exciting.